Picture an oil refinery processing 200,000 barrels of crude oil per day. The chief security officer, alarmed by the rise of FPV drone strikes on energy infrastructure, secures a $2 million budget to harden the facility's airspace. A leading defense integrator arrives, unboxes a powerful high-frequency CUAS radar system, and mounts it on the highest available structural steel mast, right above the main crude distillation unit and adjacent to a massive tank farm. The security dashboard turns green. The board of directors is relieved. Yet, within 24 hours, a routine HSE audit orders the immediate shutdown of the entire $2 million drone detection system. The radar is declared an illegal ignition hazard, threatening the facility with operational suspension. The integration team made a catastrophic amateur mistake. They installed a standard industrial weatherproof radar directly into an ATEX-regulated hazardous explosive atmosphere. Welcome back to BlackBox UAV. Today, we are analyzing the ultimate legal and physical contradiction in industrial airspace defense, the ATEX certification paradox. We will explore why standard drone radars become bomb detonators in hazardous refinery zones, the physics of RF Faraday shielding, and the exact out-of-zone architectural geometry required to secure explosive infrastructure safely. To understand why this mistake occurs, we must separate weatherproofing from explosion protection. Integrators frequently point to an IP6-7 rating as proof of industrial readiness. But an IP6-7 rating merely means an enclosure prevents the ingress of dust and water. It provides absolutely zero protection against volatile hydrocarbon vapors. In a refinery, facilities are mapped into strict hazardous zones. Zone 1 covers areas where explosive gas atmospheres are likely to occur in normal operation. Zone 2 covers areas where explosive gas atmospheres may occur during minor leaks or maintenance. In these classified zones, volatile gases such as methane, benzene, and hydrogen penetrate standard radar enclosures. When a standard commercial CUAS radar operates, its internal power supplies, high-frequency switches, and capacitors generate microarcs and thermal heat. If the surface temperature of an internal component exceeds the auto-ignition threshold of the surrounding gas, known as the temperature class rating, the radar itself becomes the ignition source for a massive industrial explosion. Furthermore, the plastic radome covering the antenna acts as an electrostatic accumulator. Without specialized surface resistance dissipation below 1 gigohm, friction from airborne dust particles can generate a static spark capable of igniting a cloud of vapor. When confronted with ATEX noncompliance, inexperienced integrators often suggest a naive fix. Just put the radar inside an EXD flameproof enclosure. This suggestion exposes a total ignorance of electromagnetic physics. An EXD enclosure is a heavy, cast iron or stainless steel box engineered to contain an internal explosion without allowing flames to escape into the external atmosphere. If you seal a 24 GHz drone detection radar inside a thick steel EXD box, you create a perfect Faraday cage. The metallic walls reflect 100% of the radio frequency energy back into the transmitter. The radar cannot emit a single electromagnetic wave into the sky, rendering it completely blind. To make a radar ATEX compliant without metallic shielding, engineering teams must use complex EXP pressurized purging systems. This requires feeding a continuous supply of clean compressed air or inert nitrogen into a specially certified, electrostatically conductive non-metallic radome, maintaining positive internal pressure to force dangerous gases out. An EXP pressurization system increases the cost of a single radar panel by 300%, adds massive mechanical weight, and requires complex pneumatic plumbing that makes high-altitude mounting practically impossible. The consequences of ignoring ATEX standards reach far beyond technical failure. They represent a catastrophic corporate legal liability. Under the European Seveso III directive and OSHA hazardous location regulations, deploying uncertified electrical equipment within classified hazardous zones invalidates the facility's commercial operational permits. More critically, it completely nullifies the refinery's multimillion-dollar property damage and business interruption insurance policies. Consider the legal reality. A facility management team spends hundreds of thousands of dollars on a non-certified drone radar to prevent a hypothetical external threat. In doing so, they install an unauthorized ignition source directly inside a Zone 1 volatile gas area. If a vapor leak occurs and the radar triggers a fire, the insurance underwriters will conduct a forensic investigation. The moment they identify a non-ATEX certified device operating within the hazard boundary, every single claim is denied. The board of directors becomes personally liable for hundreds of millions of dollars in damages and faces criminal negligence charges. Buying expensive hardware without verifying its environmental clearance is not security. It is corporate negligence. How do you resolve this engineering deadlock? You must abandon the idea of mounting radars inside explosive processing areas and master out-of-zone architectural geometry. True CUAS site architects do not force expensive, heavy EXP radar systems into hazardous ATEX zones. Instead, they calculate precise standoff distances, placing standard high-performance micro-Doppler radars outside the classified hazard boundary, on safe perimeter fence lines or non-hazardous administrative towers. By adjusting elevation angles and calculating tangential grazing rays, the radar beams pass over the hazardous tanks and processing units from a safe distance, illuminating the airspace above without placing a single watt of uncertified electrical equipment inside the volatile gas envelope. Within the dangerous Zone 1 areas, architects deploy only passive, fully certified EXD thermal imaging sensors and stainless steel acoustic arrays that carry legitimate European notified body certificates. Security is not about bolting hardware to the nearest mast. It is about rigorous physical geometry, regulatory compliance, and understanding the threat ecosystem. If this engineering breakdown protected your facility from a $1 million procurement error, hit the like button and share this data with your HSE and security teams. Subscribe to BlackBox UAV for uncompromising aerospace analysis. For direct engineering consultation on hazardous site geometry calculations, ATEX compliance audits, or custom refinery defense specs, find my secure contact link in the pinned comment below. We deliver uncompromising engineering truth. Stay secure, and I will see you in the next analysis.